On July 26, 1971, the Apollo 15 space module touched down on the moon, and astronauts emerged with the new vehicle, the Lunar Rover. They took it for a test drive. It handled well on the rough surface of the moon, so they could venture further from the landing site and really explore. The Lunar Rover was no ordinary four-wheeler. Millions of dollars of research went into this one-horsepower wonder, which became known as the moon buggy. Today, craftsmen build replicas for space museums and to use as movie props. The team starts with a substantial suspension system designed to smooth the ride over the moon's rocky terrain. They then install a steering plate at the front. They attach actuators, which are mechanisms that assist in steering. They connect the actuator drive bars to the steering plate. Together, the steering plate and actuators give the Lunar Rover an incredibly tight turning radius of 10 feet. They screw support brackets for the actuators to the corners of the chassis. They then connect the actuators to them. They use steel and aluminum bolts and parts. However, on the original moon buggy, many parts were made of titanium because it lightened the load carried into space. Titanium is expensive and unnecessary for this replica. The fenders are next. They are extra large to protect astronauts from lunar dust kicked up by the rover. They insert a locking mechanism in a slit at the end of the drive shaft and slide the wheel hub onto the shaft. They turn the hub to lock it in place. They're now ready for the wheels. In the atmospheric vacuum of the moon, air-filled rubber tires were out of the question, so the original rover had wire mesh tires. To mimic the look, they've wrapped a wire lattice around rubber tires. The team secures the wheel to the hub with a plastic and aluminum cap that's equipped with locking pins. They give it a spin and install the other three wheels. Next, a technician assembles the instrument panel. He inserts various switches and gauges into their slots, including this system reset switch. It's used to bring the displays back to zero prior to an expedition. He closes a two-piece collar around the bottom of the switch. He locks it in place with the top cap. He then flips the panel around and tightens the nut on the back part of the switch. With the system reset switch now attached, the instrument panel is complete. He places it in the housing. He installs metal bars around the switches to keep them from being accidentally tripped. He assembles the steering handle, which is a T-shaped joystick, next to the instrument panel. They now transfer the steering and instrument panel assembly to the vehicle. They fasten the actuator switches to the steering housing and then clip the wiring harness to the floor of the Lunar Rover. They cover the bottom of the rover with flame-resistant material. They lower the electrical control panel and battery into the chassis and connect them. The original rover had 2 small batteries, but the mechanics of this replica have had an update. Stay tuned for more as this Lunar Rover replication mission continues. The original Lunar Rover weighed just 460 pounds, or 77 pounds in moon weight. It could carry a load of over twice that. In minimal gravity and an atmospheric vacuum, it was the only way to travel on the surface of the moon in 1971. The production of this Lunar Rover replica continues with the fabrication of a brake disc. The technician carefully measures the dimensions and draws them onto a sheet of plastic-covered aluminum. He drills a large hole for the main drive shaft and 4 screw holes. He then cuts out the disc following the penciled lines. He smooths the rough edges using a fine grit abrasive belt. He sands off the plastic liner and abrades the aluminum surface to a satiny sheen. The brake disc is now ready for assembly to the Lunar Rover. He attaches it to the main drive shaft and lowers the assembly into the vehicle. He bolts the disc to the chassis, where it will serve as a friction surface for the brake pads. He installs those next. He connects it to a spring mechanism for engaging the disc brake. He tests the drive shaft and disc brake and confirms that they're both in working order. He loops a roller chain around the sprocket gear for the rear-wheel drive and the teeth intermesh. He drives pins through the links to join the ends, closing the loop. This drive chain is powered by an electric motor. It's another mechanical modification. On the original Rover, there was a small motor for every wheel and no drive chain. The lawn chair-like seats are next. They cover the shocks and battery at the front with an aluminum hood. They also install a cover over the mechanics at the back. It doubles as a rack for geological excavation tools. They attached the umbrella antenna to the rover. It was used to beam pictures and data to Earth. Next, an aluminum cylinder spins in a lathe as cutting tools transform it into a camera mount. They also create a bracket for a communications antenna. It's quite a transformation. Using the bracket, a member of the crew now erects the communications antenna. He then installs the mount for the film camera. Next, using a shear press, he lops off a piece of an aluminum sheet. He switches to a hand tool and cuts out a geometric shape with flaps. He folds up the flaps using a brake press, creating a box to cover the main battery. After the seams have been welded, he wraps the cover in mylar, which is a strong plastic film. The wrap is an extra layer of protection against windborne particles, known as micrometeoroids. They also wrap the camera and other parts of the rover with mylar. This replica of the Apollo Lunar Rover is complete and ready for display.